Now we'll discuss about due to the power cut. The video has divided into 2 parts here. Now we'll discuss about DC motor. The application is mainly in the regenerative braking application. So boost converters plays a vital role in that. Here, the DC motor undergoing uh, regenerative braking. Regenerative braking. How we use the DC motor in the case of a regenerative braking purpose. Okay, right. Let me take the circuit here. So we have a VS and we have a switch. And we have an inductor and we have a DC motor and we do have a freewheeling diode. This is LA. This is a armature inductance. Armature inductance. This is the RA. Now, so now generally, so during the motoring operation, you know that you are supplying this voltage. The input voltage is the input voltage here. This V input supplying here, and this switch will be, and this motor during the motor operation, the switch will be acting as a buck converter mode. Buck converter controlling DC motor, we'll call as this one. Now when the switch is in a buck converter, it will give energy to the motor, so that, and during the motor operation, when the motor is rotating, thereby wheels are rotating, it's normal, right? So when the motor is rotating, there is some EMF is produced in the motor. So that EMF we call as back EMF, right? When the motor is rotating, I will be taking a rotation in this W angular speed here, and you know that the electrical torque is also in the same direction. TE torque T is also in the same direction. Okay. Now you know it is taking the current of armature current from the supply IA, and the IA is flowing here. Thereby, the flux will produce here. Thereby, with the rotation of mechanical energy production here. So the rotation of mechanical energy is cutting the flux. Thereby, an EMF is produced called as back EMF, which is opposing the supply voltage or input voltage. And during this time, so the rotation and also the torque, electrical torque here, we can call it as. Okay. Now come to this is the general motoring operation. Okay. General motoring operation. Now, when you want to operate in a regenerative braking, so when you want to operate in the regenerative braking, so the circuit is like this. We have to modify this one here. So this is circuit VS, and we have a diode, and we have a inductance. Now the switch is come into the picture here. Okay. Now we have a motor. Right. So it has some armature resistance RA, and again the same, the back EMF is produced here, and it is also rotating the W. Okay. As you know, this is the inductance, armature inductance. This is the thing here. Here, during this operation, during the regenerative braking operation, if the armature inductance LA is not sufficient to boost the value, so ensure that we have to connect an external inductance to boost the voltage, here what we have converted from buck, right? Assume that. So it is operating with the 200 volts, but we have to boost up to 220, because So at the initial position, what we have, it is a 220. So by using a buck converter, we have stepped up to 200. Okay. Now when you want to boost here, so it has to maintain its voltage, right? At the time, if this inductance is not sufficient, okay, we have taken external inductance to boost the voltage. Okay. So to match here, to match the voltage, we have to use an external inductance to match this voltage. Okay. So if the inductance LA is sufficient, is fine. If it is not sufficient, we have to add an external inductance to step up the voltage from 200 to 220. Okay. That is the one point to be noted here. If the armature inductance is not sufficient to boost the value, ensure an external inductance is to be added to boost voltage from a, we call as buck voltage, from a buck voltage. Okay. Now, as a machine feed back the electricity by means of regenerative braking. So whatever the kinetic energy, like for example, so when the kinetic energy decreases, so you know that we are supplying the energy. Like if we have a 200 is there, we have to boost into 220. We are regenerative, giving a back. Okay, regenerative backing. So by boosting the energy. Okay, so as you are boosting the energy, here what happens? So as time being, kinetic energy will be decreased because the speed of the vehicle decrease means the kinetic energy decreases, thereby speed decreases, and thereby the back EMF is also going to decrease. Okay, so assume that previously we have a 220 was 200 was there. Now the back EMF is came to 180. Okay, 180, right? Up to this also, again we have to add an external inductance again to boost up to 220. Okay, so even the kinetic energy decreases, the speed decreases, so even the back EMF decreases, we have to add an external inductance to boost our voltage up to 220. So in the means of regenerative braking. Okay, now that's what we have to add an external, okay, external inductance to boost the energy from 180 volts to 220 volts. And we have to also, while adding the external inductance, we have to close the switch for a long time. Close the switch for long time. As I told you previously, right? When you close the switch for a long time, inductor stores the energy for a long time so that the boost value also more. Now also, even the back EMF decreases. We are adding external inductance. So at the time, we have to switch on the, we have to on the switch for a long time so that it stores the energy for a long, so that it can able to match our required voltage of the boost limit. Okay. Now we'll discuss about the duty ratio increase here also. Now when you when you're operating here, the duty ratio of the boost converter also has to be increased here. Okay, as you said, it is you are closing the switch for a long time, right? Along with that, the duty ratio of boost converter switch, has to increase because when you increase the duty ratio only, then only on time will be more, then only it will boost the energy. Okay, during the motoring action, what is the equation during the motoring action? Or else you can take this one as the motor as a generator, motor acting as a generator. So now, so the EB will be a source now. So now the EB will be acting as a source because it is supplying the energy, right? It is giving back to the voltage VA. Along whenever it is giving back here, there is a drop of IARA will be there. So if I write the equation here, EB is a source. So from the source, there is a losses and there will be a IARA. So right, so EB minus IARA will give VA. Okay, if you subtract the ARA losses minus from EB, then you are getting the total VA. Okay, so at the time, what will the torque here? Torque also going to be reversed. Okay, torque also going to be reversed. So the electromagnetic torque T, as is mentioned here, so this will be in reverse. Earlier, when it is acting as a motor, this will be T in this direction. Now the T also getting reversed. Okay. Now, what is the Vs value? Vs is equal to Va divided by 1 minus D. Okay. Vs is equal to Va divided by 1 minus D. So in the case of boost converter, what we have taken is V out is equal to V in minus 1 minus D. Now here, what is this is the perspective of regenerative braking. Okay. Vs means this is the output, right? What is source voltage we have taken here? Okay. Now Va means the voltage across the motor divided by 1 minus D. Okay. So this is the case here. Now, so this is a new, not a new discussion. Previously, there is an expression. There is an expressions previously also regarding based on this. So previously we used to call them as buck converter as class A chopper. So which is come in the power electronics, right? Class A chopper. Boost converter as class B chopper, and both combined buck boost we call as both converter is in class C chopper. Class C chopper. Okay. So now together we'll draw a diagram here. So when this in the motor action, so this is a supply voltage. We used to have a switch here. Okay, we used to have a switch, and then we used to have inductance here, and then we have a motor. So this motor is going to drive this here. So this is a switch S1, this is inductance LA, and we have a diode here. Okay. Now this is IA is here. IA. Just a minute. Now, this is during the motoring operation. So, right, there will be a back EMF EV produced here. So, during the motoring operation, during the motoring operation, EB is equal to VA minus IARA. Now, when you want to operate this in a regenerative braking, so we have to do some extensions here. So, here we have to have a switch. We have to have a switch here, and we used to have a diode, one more diode D2. Okay. Now the EB is here, it is here. Now after during the regenerative braking, it is giving a current IA, and this will be S2. Okay. And this is a normal circuit. This in this circuit, so both motoring. So this is in the case of generating mode, and this will be the motoring mode of current. Okay. Now in this regenerative braking mode, what is the EHB here? Regenerative braking. EB is equal to VA plus IA RE. Okay. So when the switches S1 and D1 are operated during motoring mode, and S2 and D2 is are operating in regenerative mode. Regenerative braking mode. So this is about the operation of the motor, both the both the modes here, both operating modes, motoring mode and also regenerative braking mode. Thank you.